Where do you start? Let's work with the numbers first. Okay. So if I work with the numbers, you have 3. Is that being raised to a power? It's in parentheses with this little negative exponent out there. So 3 is being raised to the negative 2 power. What about the 9? Yes, it's also being raised to the negative 2 power. So as we start, we want to just look at what's going to be the number part. So in the numerator, you have 3 to the negative 2 power. In the denominator, you have 9 to the negative 2. What do we do with those? We want to make them positive exponents. So I'm going to move the 9 up, making it 9 squared. And I'm going to move the 3 down, making it 3 squared. What is 9 squared? 81. What is 3 squared? 9. And 81 divided by 9 is 9. I'm just going to do a little fancy thing around there. That's going to be the numerical part. That's the number part of your answer. Okay, so now what we want to do is we're going to focus on, let's focus on the variables. So I'm going to look at these variables here, highlighted in blue. But I'm going to ask myself, this very first x squared in the parentheses right next to that 3, is that being raised to a power?
Yes.
Yes, what power? To the negative 2 power. What about the y in the denominator? Yes, that's being raised to the negative 2 power. So the first place that we want to focus is working on this right here. When you take a power and you raise it to a power, you see those parentheses, which designates what operation? Multiplication. So the variable part, you're going to have x to, what's this become? A negative 4 power. You have y to the 0, and you have y to the 5th. In the denominator, what does this become? Y to the negative 2nd. So you have y to the negative 2nd, y, which is understood to be to the 1st power, if some of you need to put that there. Then you have y squared, and you have x to the negative 3rd. So let's simplify the numerator. What are you going to do to exponents of like bases now? Add. So you have x to the negative 4th, y to the 5th. 0 plus 5 is 5. In the denominator, you're going to have x to the
1.
No. What power is x to? X to the negative 3rd, and yes, y would be to the 1st. But now what do you do with those? Yeah, we're going to move them up, which changes the sign of the exponent. And now what do you do to those exponents? Add, which is going to give you x to the negative 1st, y to the 4th. And what was that number we said we need to associate with that? The 9. So here's what you have for an answer. Don't forget to bring that 9 over here and tack it on. Question. Thinking caps. Okay, what we want to be able to do today is come up with some equations. We're going to be looking at word problems, being able to change those and put them into an equation. And then we're also going to be looking at how to solve problems that are fractional parts of a problem or fractional parts of a number. So as we go through, when we talk about having something written into words and trying to convert it over, there's certain words that are going to designate certain things. Like if you hear sum, what do you think of? Addition. Difference. Subtraction. Difference is subtraction. Quotient. Division. Product. Multiplication. If you hear the word factor, that's numbers you multiplied together. Something else. What does the word of mean? Multiplication. The word per. Divide. Per means divide. That's why when it says 70%, that means 70 divided by 100, because cent is a prefix for 100. Centimeters, century. Something else we have is the word is or was. What does that refer to? Nope. What is? Is or was? An equal sign. Yep. That's going to refer to equals. So what we want to do is take this and convert this over. So I'm going to break it into parts. The first thing says twice a number. How do we show twice a number?
2 times x.
2 times x. X squared, they would say a number squared. Okay. So twice means, if I just say, what's twice your age? How do you calculate it? Do you take 15 and square it and say you're 225, or you take it times 2? You take it times 2. So twice a number means 2x. Now here I know the next thing I see is the word is, and I said that means equal to, but we need to finish reading it. It says is decreased by 7. So what does that mean? What's decreased mean? Subtract. So I want to subtract 7. This quantity is multiplied by 3. So how do you show that? This quantity means you need to put it in parentheses. Multiplied by 3. Some of you may put the 3 here because you think you have to go in the order that it's written up here. But multiplication with a 3 there, what happens if I put the 3 there? Does that look better? Yeah. Yeah, that looks like something that we're used to seeing. So the quantity is being multiplied by 3. Now we get to the result is. What does that mean? Answer. So that means equals. The result is 9 less than. So if I tell you that your age is 30 less than mine, what would you do? Do you take minus 30 and then figure out what my age is? No, you take my age and then subtract 30, right? So when it says 9 less than or greater than, you want to save a place because you got to take 9 away from something. So 9 less than means I'm going to subtract 9, and I'm going to subtract 9 from what? 10 times the number. What's my number? 10x. X is your number, so I got to take 10 times x. You have an equation. That's working with a word problem, converting it into an equation. But the question says not what is the equation, what's it say? What is the number? So what do we have to do after we get that set up? Now we got to find x. Now we have to solve. So if we solve, what's the first step you need to do? Yeah, we're going to do the distributive property, which is going to give you 6x minus 21. And the right-hand side is already simplified with 10x minus 9. What's the next thing you do? Oh, this is a nice color. Let's check this out. All right, we want to move the x to one side. Which way do you want to move it? We're going to move the 6 over. What does it become over there? Negative 6. And we're going to move the 9 over, making it a positive 9. What is negative 21 and positive 9? Negative. Negative 12. And on the right-hand side, you end up with 4x. So then what do? Divide by 4. Divide by 4, and what is x equal to? Negative 3. Now you could say, okay, twice a number. So if my number is negative 3, what is it now? Twice means negative 6. is decreased by 7. So if I subtract 7 from that, what are we at now? Negative. They're both team negative, negative 13. And that quantity is multiplied by 3. If I take that times 3, then what do you get? Negative 39. The result is 9 less than 10 times the number. What's 10 times your number? The number is negative 3. 10 times that is negative 30. And it is 9 less than that, which is negative 39. It agrees. So your answer is x equals negative 3. Question. Making sure you can put it into this statement right here is where you really need to focus. So let's look at another one. Oh. Where do we start? Well, let's read through. The number of the ducks on the pond was doubled. How do I double that? Times 2. So the number of ducks was doubled. Then what? 7 more ducks came. Plus 7. 7 more ducks land. The resulting number of ducks was, what's that mean? Equals 13 less than, save a space and put minus 13. 13 less than 3 times the original number, which is D for ducks. 3x. I just put a D for ducks. All right, how do we solve?
3D over.
We can move the 3D this way, which makes it what? Negative 3D. And if I move the 7 over, it becomes negative 7. And I get negative 1D is equal to?
Negative 1.
Yes. And then? No. Divide. This is being multiplied, so you divide by negative 1. So how many ducks? How many ducks were there to begin with? 20. We had 20 ducks to begin with. And then we had a new flock land. And what that did was double it. So we were at 40, and then 7 more came in, then you're at 47, and that's 13 less than 20 times the original amount, which was 60. 20 times 3 is 60 minus 13 gives you that same value. Okay, question on that one. Try writing this one. Okay, I need to intervene. The sum. What's sum mean? Adding. So I want to find the word and. So I'm going to figure out what am I adding together. Okay. So the sum of negative 7 and 6 times the number. So I need to add 2 things together. What am I adding together? Negative 7 and 6 times the number. How do I show 6 times the number? 6x. So sum, find that word and see what you're adding together. Well, now we got this little thing again. It is multiplied by 5. What's multiplied by 5? The sum is multiplied by 5. So as you kind of read it, it says the sum is multiplied by 5. So what sum? And that sum is negative 7 and 6. Now we get to this part that says the result is, which means what? Equals. And then I have 332 less than So you're going to save some space and put negative 332 because less than you're going to take away. And then we have 3 times the number. Oh, I did orange again. Sorry, I want to try to keep these as separate colors so you can see where everything comes from. Can you see that teal? 3 times the number. All right, what do we need to do?
You gotta throw
Distributive property, negative 35 plus 30x equals 3x minus 332. Which way do you want to move the x's? Oh, wait, what did I do? Oh, okay. I could do something wrong, so don't be afraid to stop me. Okay. Now what? I'm going to move the 3x this way to make it negative, and move the 35 over and make it positive. Oops. That's all right if I write it on both sides, I guess. So 27x is equal to?
297.
Negative 297. Oh, do you know what that is divided? Oh, come on.
11.
Yeah, 11. Because remember what I said when you multiply by 11? You separate the 2 and the sum goes in between. But it's not 11. It is what? Negative 11. X is negative 11. I guess the new part with this one was recognizing the sum is what is being multiplied by 5. So you got to be careful of that part. Are we good? New slide. New concept. We could write this as equations and solve equations. But if I were to solve something and you see something like this, what do you do to solve? We have a box diagram. We solve by just cross multiplying and dividing. So we want to set up ratios or a proportion in order to solve. Label off to the side, please, because that's what gets some of you into trouble. We look at this and it says 1/5 of the clowns had red noses. What does that mean? 1/5 of the clowns had red noses. One has a red nose out of 5 clowns. Okay, so we have red noses. Should be doing this in red, not blue, right? And we have the total. So 1 out of 5 clowns have a red nose. How many do not have a red? 4. So if I just had 5 clowns, 1 would have a red nose, 4 would not. If I had 10 clowns, how many would have a red nose? 2. How many would not have red noses? 8. And air. I'm waiting for the tip to fall out. It's either the bottom half or the tip falls out of my pen. Okay, but what do they tell us? If 30 clowns had red noses, so I want to go with red noses and I want to put 30. 30 clowns have red noses. How many clowns were there in all? What am I looking for? A total. How do you solve that? I do not need this piece of information. So what we do is we cross multiply and divide. So 5 times 30 is 150. Divided by 1 is 150. Very good. I was hoping you would get that one. All right. So 150 clowns. I have 150 clowns because I have 30 that have red noses. And that reduces 30 over 150 reduces down to 1/5. That's all they're saying. You're just coming up with equivalent fractions. Is that your pin cap too? Question. I like the box diagram better than the equations for this. So we look at another one. Uh-oh. See? There went my, speaking of it, there went my tip. So what happens for this problem? We have the Tartar horde, road horses, right? How many? No. 7 eighths. 7 out of 8 ride horses. Road, ride, okay? Whichever way you want to look at it. So this is how many do not ride, right? How many do not ride? 1. There were 140,000 in the horde. Where does that go? Total. How many did not ride horses? Top or middle box? Top is what they're asking for. How many did not ride horses? I can get rid of this 7, or you can use the 7 and find this value. But if you find that value, then you need to subtract to find the top. Subtract it from 140,000. But otherwise, what are we going to multiply together in this problem? 140,000 times 1 and divide by 8. Do you see how you cross multiply and divide? So 140,000 times 1 and divide by 8. Some of you got to do it this way probably. Divide by 8. 8 goes into 14 once, which is 8, leaves you with 60. How many times does 8 go into 60? 7, which is 56, which leaves you with 40. 8 goes into 40 5 times. You better bring down 2 more zeros. So how many did not ride horses? 17,500.
When they're on the.
Yeah, I said 17,500, right? Is that not what I wrote down?
17,000, 5,000.
I said, yeah. I said 17,500. Is that not what I wrote down? Are we good? Let me do it to you this way. Oh, I don't know whether to make this an exit ticket or to do it up on the board. Exit ticket. What you need to do, there's 2 of them. Okay. All right, so we're going to have this, your exit ticket, so I can look at it. Your exit ticket is page 41, A and B. Page 41, A and B. Tomorrow, what are you going? Where are you going to be? In the back. Now, here's the problem. I'm gone on Monday. So tomorrow, you will be working on lesson 5, 1 through 30. You've already done 16 through 30. You worked through that. I did not answer questions over that, did I? Just add to it, and I want this due on Monday, all right? And I don't care. You can go ahead and put the 16 through 30 in front if you just want to keep using the same sheet of paper. Yep, you may keep that. But 1 through 30, wait, oh yeah. Okay, I'm going to say due Monday, but we'll see. Monday, you might be working on IXLs, and we'll talk about this on Tuesday, because we'll talk about this on Tuesday, because I'm gone Monday. Okay?
No, I'll probably be here.